In this example, we are given an isosceles triangle. We're told that DE is congruent to FE, or DF, sorry, is congruent to FE. So these two kind of vertical legs are congruent. And we are asked to describe the points here of the vertices. So describe the vertices in as few variables as possible. And we are given that this one, it's a little hard to see in this picture, is 2a, comma, question mark. There's a whole bunch of question marks. Everything else is a question mark. All right, but we also can see that this point D appears to be have been placed right at the origin. And so let's say that that's exactly what that is. So this is actually the origin, which is the point 0, 0. Remember, when you put coordinates on when you define coordinates, you're allowed to put the origin wherever you want, but then you have to, live with the consequences of that. So in this case, we can put our origin at D, and we're going to have to figure out where everything else is. We're not going to be allowed to just make up whatever we want for those. So right now we have that our point D is the origin. We're told that E is 2a. Now this point E is also on the x-axis, right? It's on the x-axis, so the height at this point is 0. All right, so our point E, we can say, is 2a, comma, 0. So now we've got our base, our DE, is on the x-axis. It's directly on the x-axis. All right, we need to take advantage of some facts that we know about triangles, in particular about isosceles triangles, and that is that the altitude is also the median, right? For an isosceles triangle, the altitude from this vertex here is also the median. So this is perpendicular and it's a bisector, right? So if we call this point M, then that's the midpoint of DE. If DE is in E, or if these 2 points are given by this, right, then their midpoint is going to be what? Well, it's going to be half the distance between these two, so 2a divided by 2, and then half the distance between the y coordinates, but that's already 0. And so the midpoint here is a, 0. And that's why I think the text chose to put 2a here instead of just a, but there we go. So the midpoint is at the point a, 0. And notice that the midpoint is sitting, because of this property, directly below this point F, right? And so the point F up here must have the same x coordinate. It's over the same amount in the x direction. So this has to be a. But now at this point, we can't say anything about the height. I mean, we could start counting boxes and then relating them to a. Maybe they want us to do that. I'm not really comfortable doing that though, so well, we can do it. So let's just first say that this is h. Okay, so that's the height. So the height here, notice that we have a now. So this is a, right? This is the x value a. Every 3 boxes is a. So a equals 3 boxes on our scale. We don't know what a is. A might be a big number, it might be a really small number, it might be 1, right? It might be a third, it might be 3, who knows? But what we know is that on our scale here, on our grid, a is 3 boxes. And so then we can count up here. So 1, 2, 3, 4, 5, 6, 7, right? So F is at a height of 7a. So 7 boxes. H is at 7 boxes, right? And then what we can do is we can use this ratio, right, to solve for h, in terms of a. All right? And so then h is equal to what? It's going to be 7/3 of a, right? So for every 3 boxes, we get a here. So let me just write this down. So 1 box is equal to a over 3 by this logic, right? And then just take box and replace it here. And so this becomes 7 times a over 3, or exactly this. H is 7/3 a. All right, so that means that actually our point F, if we're going to go back over here and write down our final coordinates here, the coordinates of F are a and then 7a over 3. And if we want to evaluate the area of this isosceles triangle, that was the last part, right? Compute the area. We can write it totally in terms of a then, because we have this ratio for the height. So remember, the area of an isosceles triangle for any triangle is 1/2 base times height, right? But for an isosceles triangle, it's going to just be the coordinate of the midpoint. I mean, it's written the same way, right? 1/2 base times height. But this 1/2 base is exactly a, right? So this is our a. And our height we know is 7 over 3a. And so the area of this triangle, depending on what a is, this is going to be given by 7/3 a squared. And that's the area. All in terms of a. As you change that a, that variable a, it's called a parameter here, but this variable a, as you change that, the area will change by exactly this ratio, as long as you're not moving f up and down, right? So, sorry, f will move, but it'll move in terms of changing of a, right? But that's it. So it doesn't depend on anything else. It just depends on a. And so there you go.